So we'll start the class. It's audible and visible. So let us continue the discussion where we have stopped. Last class I told construct the standard array for a given G, and hope all of you have written all the code words and H transpose H. This you have completed, and this is where you have stopped in the last class. These are the code words, and we have discussed a table also. This I asked you people to prepare, and hope most of you have completed at least first row and first column. May I know? Otherwise I will wait for you people. Prepare this table now. Yesterday I think you couldn't complete this. I will give you 1 minute. Complete this. Simply have to write these code words what you have taken in the last class in the first row, and H transpose you are writing, that's all. This side the starting is 0 0 0 followed by H transpose of continue writing. First row is all the code words. Vidya has completed. Let others complete. Now all of you have completed. The next step is very simple, but it may take a little time, but it is very easy to understand. While writing you have to take care, that's all. The next step is write a code word with the first bit change. This is a code word. This is a reference. Similarly, this is a reference. Make a second bit change and write down. Similarly, continue. Last one, write on the first code word only with a 6-bit change. Observe carefully. Write down. You can cross verify whatever you have written. After a minute, I'll show you. This is a reference. First bit I am changing. This is a reference. Second bit I am changing. This is a reference. Third bit I am changing. This is a reference. Sixth bit I am changing. Okay. Most of them they have completed now first row. Let me show you the first row. Compare what you have written with this. I am sure it will be same. If it is same, you write down same. Now, let us go to the next. If you write a second row correct, then most of the work is done. Let us go to the second column. What do you have to make? Take this as a reference. Make changes in the first bit for this. Make changes in this second bit, write down. Repeat the same thing. Try to understand. 0 0 1 1 0. Make a first bit change, write down. For this only make a second bit change, write down. For this only make a third bit change, write down. That's all. I'll give 1 minute. Complete it. I'll show you my entries. You can compare it. Most of you have done it. Within a minute you have done it. So definitely most of you understood. Let me show my entries. And this is a reference. I am making changes, and now I have written this. Just compare what you have written. Entries are same or not. Here and there sometimes there may be a small mistake. Make changes in that and rewrite. I'll wait for you people to type same sir. And most of them they have written it as the same sir. So the same thing now. You have become expert. Let us go to the next and write down for the second column. Procedure will remain same, and take this as a reference and make changes in the first bit, make changes second bit, third bit, fourth bit, fifth bit, sixth bit. Follow the same procedure for second and third. Complete 2 now this time. I'll show you the answer. Take a 2 minutes. Try to complete the second and third. Then those who are completed, they can continue. But after second and third, I'll show you my entries. You can do the comparison. Now you can compare those who are completed. Somebody told it is same, others can do it. Those who are completed writing up to third column, they can compare. If it is same, let them continue fourth, fifth, 6th, 7th. I'll show one by one. You people can compare. Continue till a last column. Procedure is simple, but it takes a time and you should have patience. That's all. Nothing, it's not a difficult or anything. It's very simple, but you need a little patience. It takes a little time. Up to 5th column I have shown. You people can compare and continue the 6th and 7th column. All these are typed by me only. A table is prepared by me only. Now I am showing you the 6th column. Somebody has completed. Very good. A 6th column I am showing. Complete that. 7th also you can complete. The 7th column also I am showing. Just compare it. And this is a standard array. A complete standard I am showing you. Just compare all the entries with what you got. I'll wait for a 1 minute. Very good. Many of them, they are telling that they have completed. So let us go to the next. What is the use of this standard array? How to make use of this standard array? So before we go to that, so take one small example. Now let us consider I have received R equal to 100, 100. S transpose is known to us. Let us find RH transpose and find the syndrome S. Type that in the chat box. Sir, it is 001. I'd like to have another student to complete that. I'm sure 001 is the correct answer. What I got is a 001. Yeah, Priyanka also told. I too got a 001. The answer is correct. For this, if I received, syndrome is 001. Which bit is in error? Can you type in the chat box? Which bit is in error in a received 100100? Counts a bit. Yeah, it is a 6th bit because 001 is a 6th entry in the H transpose. Now let us go to the standard array. What do you have to do? Say received is 1000101 I have taken. Let us consider 100101 I have taken. Even you can take 100100 also. Now you have to check this in the all the entries in this particular standard array. So 100101 you have to compare with each entry. So when you compare each entry, somewhere it will matches. I want you people to type that row and column. Someone has given the answer. Instead of column they have mentioned row, instead of row they have mentioned a column. I got confused, I was searching here. Yeah, so it is here only 100101. So this is correct. Now what you have to do, received is this. I am comparing. So when I compare, I found this here. So in this I select the code word. See, for example, I got a correct code word, then definite is in the first row only. Automatically there is no syndrome at all, means there is no error. So let us consider if I receive 100100, which you had done, RH transpose you had discussed just now. The syndrome we got 001, all of us. Now if you take this 100100, so this is there in this position, the 4th column and the last row. So what I had to do, so coset leader is 000001. For this I see the coset leader and this I will add with this. So when I add this, so E and I add automatically 100 plus 100 plus 00001. When I add, I'll get a 100101. I'll get a original code word. So try to understand. I will wait for a 1 minute So whenever I receive any R, I mean to say a code word I am receiving as a R, that will be compared here. If it is in the first row, no problem, there is no error at all because syndrome itself is 0. Somewhere if I receive, for example, this I receive, simply add this with a coset leader, we will get this original code word. We'll wait for a 1 minute, go through, take us some other example by your own and try to understand. So take any code word, any one code word, make any 1 bit error, just search it in the standard array and add a coset leader, you'll get an original code word. Okay, hope all of you understood. Thank you for your replies so that it will be easy for me to go to the next. And individually you will come to know whether you understood or not in the online class. In the offline sometimes strength is more, it's difficult, but in online even 100 strength is there, we will come to know most of the students whether understood or not. Now let us take a next, a little theory part we have to discuss. I think one example is given, but I will not solve it. I take it as a homework. Okay, let us go to the next then. Most of them they have replied. Now a little questions I am asking, a little theory I have to discuss. What do you mean by Hamming distance we have discussed already? Minimum Hamming distance should be more or less according to you. And why for that particular answer? Say I have a code, in that I have a lot of code words. I am finding a Hamming distance. And whether this minimum Hamming distance, if it is more, it is good code word, or less, it is a good code word. In the G, instead of IP, they have given P and I. That's all. Okay. Let us continue this discussion. Minimum Hamming distance should be more or less, and why? Next question is, say if a minimum Hamming distance is 4, how many bits in the code word should change to become another code word? Use your common sense and tell the answer. I'll wait. So what I'm asking, this is a code word in the previous example. So when this code will become this code word, or when this code word will become this, when this code word will become this, how many bits should change? Or when this code word will become this, kitna bits should become error, so that I have transmitted this, but I am receiving this. I am transmitting this, I am receiving this. It is possible when how many bits are changing. That is a question I am asking you people. Somebody is telling 1 bit change may make another code word. Say this is a code word. If I make 1 bit change, will it become a this code word or this code word or this code word or this or this or this? Check it before you conclude one is correct answer. I came back to the again previous slide. Now instead of row, again I came back, I am showing you in the column wise. I am transmitting this. This should become either this or this or this or this or this or this. How many bits should change in this so that it may become another code word? All of you are telling 1 bit. So for example, this bit becomes 0 to 1. Do you think it will become this code word? No. If this bit has changed. Now let me show you. For example, let me zoom it and show you people. So now if I make, say a particular this bit 1, if 1 bit changes there, am I going to get another code word? You can just think and tell. Take this to only to understand very easily. 001110 is there. This should become 010011. How many bits should change so that it will become this? Tell the simplest example. So now little bit you are understanding. See, this is a question. What I am understanding, what I am asking is, I am sending this. This should become this. How many bits should change? This I am sending. I am receiving this. How many bits should change? I am comparing only these two. Yeah. Somebody told 3. What about others? A send कर रहा हूँ, A receive कर रहा हूँ. कितना bit change हो जाएगा? See, to become this code word to this code word, now this should undergo 3 bits change. Now what are the Hamming distance? This we have already discussed. So one code will become another code word when minimum, D minimum, what you have discussed. those many bits if changed, automatically one code word will become another code word. This I wanted to conclude. So let me go to the slide where I have stopped. 273, yeah, we are here. Say if a minimum Hamming distance is 4. How many bits in a code word should change to become another valid code word? Yeah. So now you are telling if a minimum Hamming distance is 4, sir, one code word will become another code word when 4 bits are changing. So this is basic which you have to understand. Now the symbol, all of you know this delta equal, it's nothing but a defined. So this is the epsilon. These are some of the terms you have to know. A minimum distance determines the random error detecting and correcting capability of the code. Now according to you, a Hamming distance should be more or less for a better code word. Can you type any one word, more or less? When it is a more is good, or when it is less is good? Okay. If the number of Hamming distance is very less, means probability of becoming one code to the another code word is more or less. अगर एक ही है, let us consider Hamming distance is 1. To change one code to the another code word, only one bit error is enough. Yes or no? If the Hamming distance minimum itself is 4, just now you told, कितना bits change होना चाहिए to become one code word to the another code word? 4. So do you think a Hamming distance should be more or less for a better code word? Is the question clear? I am not asking error. अगर Hamming distance ज़्यादा हो तो good or कम हो तो good. Among these 3 code, one is having a 3 Hamming distance, another is having a 5 Hamming distance. Which one do you prefer, 3 or 5, and why? Okay, you are telling 3 you prefer. Why do you prefer 3 instead of 5? Reason? When I say Hamming distance is 3, one code word will become another code word when 3 bits changes. If a minimum Hamming code weight is a 5, to change one code word to the another code word, minimum number of bits should change is how many? 5. Which is better? Sentence I am convincing you. See, minimum distance determines the random error detecting and correcting capability of the code. Minimum bole to, if this itself is more, it is better. Hamming distance between the say V and W. It is a distance D stands for. Say between the two, this is a V and W is 4. Even if you can see weight of this, when I add these two, I'll get something. Weight of that is also a 4. Given a block code C, the minimum distance of a C is defined by D minimum. What is a D minimum? D minimum equal to minimum of a Hamming distance between the V and W, where V and W belongs to C. These are a code word of a C. But remember, V is not equal to W. Copied on this, we'll continue the discussion. Next slide. These are the same, some of the points we have discussed already. If a C is a linear block code, then some of the 2 code words is also code word. These things are known to you. And the Hamming distance between the 2 code words is a C is equal to the Hamming weight of the 3rd code word. Just now you have taken some example. This is a definition how we write. And D minimum Hamming distance minimum is nothing but minimum Hamming weight what you have discussed. This is the way how they define. That's all. Copy down. Try to understand. So this is the theorem. A minimum distance of a linear block code is equal to the minimum weight of its non-zero code word and vice versa. And this we have discussed many times. Just copy down and try to understand. I'm asking the same question. Old example we had. Given H was and asked the code word. We had a H and we found the code words. When one code word becomes another code word, in this case, just type your answer in the chat box. A code word है. One code word will become another code word when how many bits should change? These are code words. A little gap I have created in between. Don't get confused. Just to mention the data and parity bits. Now you count the number of ones in each case other than non-zero. So nowhere I have 2 ones. I have a minimum 3 ones I have. So therefore minimum Hamming weight I have a 3. Or I can say minimum Hamming distance will be 3. Means one code word will become another code word when minimum 3 bits changes. That is the meaning. Try to understand. So the same thing whatever you have discussed, in general it has been given in this slide. Code word V is transmitted, R is received with the L number of error bits. If the minimum distance is D minimum, if L is less than D minimum, R will not become another code word, what we have discussed so far. Hence, block codes with a D minimum can detect errors up to D minimum minus 1 or less than that. If L becomes greater than D minimum, then one code word will become another code word we cannot detect. This is what we have discussed in general has been given in this slide. Take a minute and copy down. Thanks for your message you have copied so that I can go to the next. A n comma k linear block code capable of detecting 2 raised to n minus 2 raised to k error patterns of length n. 2 raised to k minus 1 are non-zero code words, and for all those things definitely syndrome will be 0 when valid code word is there. And total combination for n bit automatically 2 raised to n in binary, all of you know, in which 2 raised to k minus 1 are code words. For other combinations, yes will not be 0 because those are not a code word. Only for valid code word I will get s equal to 0. Remaining combinations what I get, for those s will not be equal to 0. This is known to you. Lines are given, just read it twice so that you will recall what all we have discussed. If you want, you can take a 1 or 2 lines. A block code, a C, I have a minimum distance is D minimum. Let the positive integer D minimum is greater than 2t plus 1, less than 2t plus 2. C can correct the t or less than t bit errors. So if a D minimum is 5, example is given for your reference, then 2t plus 1 will be less than or equal to D minimum. It can correct up to 2 errors. Agar 6 hai sir, it can detect up to 2 errors. So if it is a 8 D minimum, it can correct up to 3 errors. So note down 1 or 2 lines, and if you want you can take a simple example for your reference. We will conclude today's class, and we'll spend 2 to 3 minutes for our discussion whatever the doubts we had today. Then we'll continue our discussion in the next class. Thank you for attending the class. Take care, be safe, and have a good day.